Hello everyone, in this video I will continue talking about this sample problem. So the next step is to determine the water content. So let's check the previous slides. So water content is determined based on this table. So we need to know the nominal maximum aggregate size, which is 1 inch for this problem, and this is for non-area entrained, and these 3 rows are for area entrained. So the concrete is area entrained, and the slump is about 3 inch. So it's the second row here, and corresponds to the 1 inch nominal maximum aggregate size. So it should be 295 pounds of water per cubic yard of concrete. And note that based on the value we got from this table is for angular aggregates, but in this problem we used rounded gravel, so there should be a reduction in the water content. So we need to reduce the water content by 45 pounds per cubic yard of concrete. So the value we get here is 295 minus 45. So water content, the 6th step, water content. From table it's 275 pounds per cubic yard of concrete minus 45. So we get 250 pounds per cubic yard of concrete. So this is the water content. In the next step, we need to determine the cement content. Okay, so let's see the previous slide. So the cement content is the water content divided by water to cement ratio. So in this problem, the water content is this value, right? And the water to cement ratio we talked about this in the previous video, is equal to 0.45. So the cement content should be 250 pounds per cubic yard divided by 0.45. So if you calculate, this is 556 pounds per cubic yard of concrete. So this is the cement content, and we need to check if we satisfy the exposure condition. So when there is severe exposure, the minimum amount of cement is 564 pounds per cubic yard of concrete. So 564 is actually, this should be the minimum amount of cement. So we need to, the actual amount we are using should be larger than this value. So you can see the value here is actually smaller than this minimum requirement value. So we should not be using this value. And the severe exposure condition in this slide is defined as severe freezing and thawing cycles, de-icers, and the sulfate exposure. So which is exactly the environment we are going to have in this project. So we satisfy this severe exposure condition, and we need to follow this minimum requirement, and so we decided to use 564 pounds of cement per cubic yard of concrete. All right. Next one is to decide how much admixture we are going to use. So from the question, you can see, so we only use the air entrainer, no other admixtures. So according to the manufacturer, we have 0.1 fluid ounce per 1% of air and per 100 pound of cement. So it's 0.1 times the percentage of air content, so which is 7%, right? Times 7, and then times the amount of cement, so which is 564 divided by 100. So if you calculate this value, it's about, so it's approximately equal to 3.9 fluid ounce per cubic yard of concrete. So this is the amount of air entrainer we need to use for this project.